All right, guys, 6.3 coming at you today. In 6.1, we went over exponent rules. In 6.2, we went over some vocab and how to add, subtract, and multiply polynomials together. Here in 6.3, we are talking about dividing polynomials. So there are going to be two videos for this. One of them on dividing using long division, that's this one, and one of them on dividing using something called synthetic division. Synthetic, you know, it might sound kind of like, oh, is this real? It might seem that way too, but it's actually a really useful technique for dividing polynomials, as you can see, as you will see, I should say. So before we get there though, before we even get to long division, there is one little preview footnote right here, and that's dividing polynomials by monomials. Remember, a monomial means it's just one term. There are no pluses or minuses. So if you look at this first example, we have 4x cubed y squared plus 8xy squared minus 12y cubed, all divided by 4xy. And that's it on bottom, just 4xy. That is a monomial. It's just one term, no pluses or minuses. And if that happens, we can actually divide this in a simple, kind of special way. Here's what we're going to do. We're just going to break it up and divide each term on top by that monomial on bottom. So if you're looking, how did I get what I got over there on the right? I'm just breaking it up and I'm saying, okay, the first term divided by the bottom, 4x cubed y squared over 4xy plus 8xy squared over 4xy minus 12y cubed over 4xy. We just break it up. This only works if we have a monomial on bottom, but if we do, it totally works, and it's really kind of convenient because now we say 4 over 4, x cubed over x is x squared, y squared over y is just y. Remember our exponent rules, we're canceling one out on top and bottom, leaves us with x squared and y, plus 2, because 8 over 4 is 2. The x's are completely gone, they just cancel. Y squared over y is just y, minus 12 over 4 is 3. It looks like we're going to have an x to the negative first because it's left on bottom. There are no x's on top to cancel it out, so we have an x left on bottom. Remember, that's what the negative means. And then y squared. You could also write it, just because I'm trying to show you every time, this alternate way to write it, plus 2y minus 3y squared over x, because again, that x to the negative first means x to the first on bottom. Either one of these are fantastic ways to write this answer. So if we're dividing by a monomial, nothing too crazy. Split it up. You can draw these bubbles if it helps you remember, but just split it up and divide everything by that monomial. Take a look at this second problem, and I want you to pause the video and just make sure you feel good about this. Bubble them, split them up. We are dividing by just 14CD. So divide each one individually, then unpause the video to make sure you're getting what I'm getting. All right, and hopefully my work matches yours. I ended up getting 2c squared minus 3d plus 4d. 4d squared, sorry, that got cut off there. Plus 4d squared at the end. So make sure that you're feeling good about this. Make sure you agree. Pause the video if you're not sure how I got that. Write a question down if you have it. But that's dividing by a monomial. That's a pretty special case. But if there are no pluses or minuses on bottom, it's a great way to go. It's not hard at all. The main focus of today's lesson, though, is on long division. Dividing polynomials using long division. So to start, we got to remind ourselves, how does long division work? So I need you to rewind it a few years. Rewind it to elementary school, whatever grade you learned this. 711 divided by 3 without a calculator. How did we do it? Well, we did it something like this. We said 711 divided by 3. And I'm hoping that this is, sometimes we have that little tail at the bottom, so put that there in case that helps. Hoping this is ringing some bells. And we said 3 goes into 7 how many times? It goes in twice. and then we multiply top times left. So 2 times 3 is 6, and we subtract it, and 7 minus 6 is 1. And we bring down the 1, and we said 3 goes into 11 how many times? 3 times. 3 times 3 is 9, multiply top times left, subtract, 11 minus 9 is 2. Bring the next digit down. 3 goes into 21 how many times? 7. 7 times 3 is 21. So there's nothing left over. We have nothing else to bring down. Here's our answer, 237. Hopefully this was a nice little trip down memory lane for you, because we need to know this procedure. And here I did it with numbers, with integers, 711 divided by 3. We're going to follow this exact same procedure for something like this now at the bottom of the screen. So that's why I like to start with the numbers. It looks a little bit easier. Let me demonstrate and show you how this is going to work. We're trying to figure out what, I'm going to write it out, 5x cubed minus 13x squared plus 10x minus 8, all divided by x minus 2. Sometimes you also see like a little hoop there, so if that helps you remember, I'll put that there for you. So, couple things. First, everything has to be written in descending order. We talked about descending order last section. So you can notice inside there, I have x cubes, then x squareds, then x's, then no x's, so that's in descending order. Outside I have x minus 2, that's in descending order. I'm good to go. All we are paying attention to each time we complete this process is just the leading term. And here's the question we're going to ask. Not how many times is x going to 5x cubed. I'm just going to rephrase it slightly. We're asking basically the same question. I'm going to ask x times what would give me 5x cubed? So x times what can I write up top that would give me 5x cubed? And the answer, I'm hoping you would agree, is 5x squared. X times 5x squared equals 5x cubed. Notice that right now for that step, I ignored the minus 2 over here. I ignored this minus 2. I ignored everything else that's inside there. All I'm worried about is those leading terms. X times what equals 5x cubed. Okay, now that we got that, let's go back to our kind of what we're used to doing, what we were doing with the numbers. I'm going to multiply top times left. So 5x times x is, 5x squared times x is 5x cubed. But then also 5x squared times minus 2 is negative 10 x squareds. So we multiply by both of those. We're going to subtract this whole thing. We know how to subtract polynomials. 5x cubed minus 5x cubed is gone. Negative 13x squareds minus negative 10x squareds. Remember, this minus a negative kind of turns it into a plus. So negative 13 plus 10, negative 3x squareds. So now let's bring down that next term, plus 10x. Just like we did with the numbers, we bring down the plus 10x. And our question now is, x over here, where I'm underlining it, times what could give me negative 3x squareds? And so we say, okay, x times what equals negative 3x squared? How about minus 3x's? So multiply again. Negative 3x times x is negative 3x squared. Negative 3x times negative 2 is plus 6x's. We are subtracting this whole thing. That's how long division works. Negative 3x squareds minus negative 3x squareds, gone. 10x's minus 6x's, 4x. Bring down the last one, minus 8. And we ask ourselves, x, just the leading term, times what equals 4x? How about a positive 4 up top? X times 4, 4x, And then the negative 2 times the 4, left times top, minus 8. We can see that we have nothing left to bring down. There's our answer right there. 5x cubed minus 13x squared plus 10x minus 8 divided by x minus 2. We carry out our long division, pretty much exactly the same as integer division, long division. And we get 5x squared minus 3x plus 4. So I'm hoping you see the parallels between when we did just numbers and what we're doing here with polynomials. It's pretty much the same process. Let's look at another example. What if we have a term missing? I mentioned it has to be in descending order, which x squared minus 25 is, but we're missing the x's. We're missing the x term. Here's what you got to do. X squared plus 0x minus 25 divided by x plus 5. Okay, we got to fill it with a placeholder 0 to keep everything lined up as we're doing this process. Let's see what happens. X times what would equal x squared? Just x. Multiply down, x squared plus 5x. We subtract the whole thing. X squared minus x squared is gone. 0x's minus 5x's is negative 5x's. Bring down the negative 25 and ask ourselves our next question. X times what would get us negative 5x's? Well, x times negative 5, I think. Minus 5x minus 25. We're subtracting the whole thing. Negative 5x minus negative 5x is gone. Negative 25 minus a negative 25 is also gone. X minus 5 is our answer. And we kind of know that because we can check it, because our answer times what we're dividing by should equal that. X plus 5 times x minus 5, we know that equals x squared minus 25. We could FOIL it out really quickly. But that's a quick way to check. In this case, we knew it kind of from factoring. We knew what would happen there. So this is polynomial long division. Really the same process as integer number long division. So hopefully you feel good about those examples. We're going to do kind of one more polynomial example. But before we do that, we got to do one more numerical example. Let's try this. What is 224 divided by 3? How many times does 3 go into 2? It doesn't. Okay, so we skip it. How many times does 3 go into 22? 7. 7 times 3 is 21, and I'm going through this one kind of quickly. 3 goes into 14 4 times. That gets us 12, and we have a 2 here. No more digits to pull down. Now, you probably remember back in elementary school, at one point, they said, oh, but you can add zeros on and we can put point and we can try to find the decimal representation, which is true. We're not going to do that with polynomials, so we're not going to do that right now. I'm hoping you also remember a time where this was your final answer. 74 remainder 2. Okay? 74 remainder 2. Now, that's kind of the first thing you learned in long division is, oh, so you have a remainder, and it was 2. We just take whatever number's down here, and that's our remainder. That's great. But here's the question. What is 224 divided by 3? It's 74, and I'm hoping you recognize that decimal as 2/3. 74 and 2/3. Well, we can write it 74 and 2/3 if we take our remainder over whatever we're dividing by. That 2 over 3 there. So again, I'll color code it. Remainder over whatever we're dividing by, 74 and 2/3. And that is our final answer. Now this is more similar to what we are doing with polynomials. Check it out. Last long division problem of the day. T squared plus 3t minus 9 times negative t plus 5 to the negative first power. At first glance, doesn't look like division. But remember, negative exponents, what does that negative exponent mean? It means it's in the denominator. T squared plus 3t minus 9 over negative t plus 5 to the first power, and I'm just going to leave it negative t plus 5 there. So this is a sneaky division problem. It looked like multiplication. It's really sneaky division. I'm going to set it up long division style. Negative t plus 5 on the outside. We have t squared plus 3t minus 9. And now let's start our long division process. Negative t times what will give me t squared? And the answer is probably negative t. Negative t times negative t, we multiply down as t squared. Negative t times 5 is minus 5t. Subtract the whole thing. T squared minus t squared is gone. What is 3t minus a negative 5t? So that's really plus 5t. We're going 8t here. Bring the minus 9 down. So negative t times what will equal 8t? Minus 8. So negative 8 times negative t is positive 8t. Negative 8 times 5 is minus 40. Subtract the whole thing. 8t minus 8t is gone. Negative 9 minus negative 40. Negative 9 minus negative 40. Positive 31. Now this is where we know we have a remainder. Here's how we know. The degree down here, 31, 31's the number. The degree is 0. We don't have any t's, right? Is smaller than the degree up here of what we're dividing by. That has a degree of 1, t to the first power. As soon as that happens, we know we're at our remainder. So what is our remainder? We're just going to say plus 31 over negative t plus 5. Plus, and I'll color code it the same way I did it last time actually, whatever our remainder is over whatever we were dividing by, plus 31 over negative t plus 5. And that's how we handle remainders in polynomial long division. Degree on bottom way down there is smaller than the degree of what we're dividing by. We just put up bottom, 31 over what we're dividing by, negative t plus 5, and we call it a day. So guys, long division, dividing polynomials, a little bit trickier than adding, subtracting, multiplying, which we did in 6.2. Here's the good news with long division, polynomial long division. It always works. We're going to learn a new method in the next video called synthetic division, which is really cool and really quicker, and I like it way more than long division personally, but it only works sometimes, and I'll explain then when it works and when it doesn't. But it only works sometimes, and so we need to know long division because it will work all the time. So just showing you some polynomial division. Remember, we started with dividing by a monomial. You'll see some of those on your practice problems, and you can just bubble it off. And then long division, this process that we kind of just set up here of x times what equals 5x cubed, and going from there, dropping stuff down, subtracting, dropping the next term down. Hopefully this kind of makes sense. If you have questions, pause it, rewind it, rewatch it, rewind it again, rewatch it, Google it, ask me. But really make sure you're getting this down, you're getting this material figured out. Polynomial long division, this is half of 6.3, and we'll do synthetic division, the other half, in the next video. Hopefully this was good. Let me know if you have questions, and until next time.